Alright, Honors Algebra 2, welcome back. We are starting Chapter 2. Hopefully you guys did very well on that test the last 2 days. You will probably see them tomorrow. In any case, let's start off by talking about a relation. I already gave you the information for that. It's a pairing of input values, so values you're putting in, to output values, values you're getting out. Alright, so the next thing we want to talk about is domain and range. Our domain is usually what you are inputting. So it's our input value. And then our range would be our output value. Okay? So really what this is saying is, if I have a function, well actually a function, what a function is here, it's a relation then with one output value for each input. And what that means is, let's say I go down to the vending machine and I want a Mountain Dew. I push the Mountain Dew button. I expect to get a Mountain Dew out of the machine. A function means that I push the input button, I will always get an output of Mountain Dew. If the vending machine breaks, or they've loaded it wrong and I get a Coke when I push the Mountain Dew button, that is now another output I got from that button, so it is now not a function. That is what a function is. So let's look down here and talk about functions a little more. Ordered pairs. Let me say this too actually. Usually when we're talking about our input value in problems, that is usually your x value. And then our output is usually the y value. Not always. Okay, so ordered pairs. Let's look here. If I put an x equals 3, I get out a 5. There's no other 3s, so that's fine. I put a 4 in, I get out a 5. I put a 4 in down here, I also get out a 5. That's okay. As long as it's the same output both times, you're good. I push the 5, I get a 5. And I push the 6 and I get a 5. So every input has one output. Okay? The only one that could have been scary here was that I had the 4 happen twice, but because their y value is the same, this is actually a function. Okay? Now let's look at mapping instead. My x values are -1, 0, and 1, and my outputs are 7, 8, 9, 10. If you look at this, notice that the input of 1 has two different outputs. I can get either a 7 or a 10. A 7 or a 10. So, is this a function? Hopefully you guys realize that is no. You cannot have two outputs for one input. Alright, now, let's look at the graph. Same thing. Our input or our x values are usually on the x-axis here. If I input a 15 or a 15.5, I get one value out. But what happens here? At age 16, I could either have a 68 inch height person or a 74. That is telling me that it is not a function. Same thing with at 16.5 and 17. So this is not a function. Okay? So again, input values have to have one output only. And to determine if it's a function, there's just really two things you have to do. Draw a vertical line. This is called the vertical line test. And then what you do is the line can only hit graph at one point for each function. So let's look at the next. What that means is basically you can only touch it once, the vertical line, anywhere on it. So pause if you need to, look at that. Draw a vertical line. Line can only hit graph at one point. So let's look at A through C here. Again, vertical line, I draw my vertical line. Oh, right there. This triangle, I hit it in 2 spots. Here's another spot where I hit it in 2 spots. So then what I was saying was that this can be this is not a function because it hits it into 2 spots both times. It only has to happen once though. So let's look at this one now. I'm drawing vertical lines. It only hits the graph at one point. Now, here, even though there's a dot here, it's open, which means it doesn't really exist here. There's no value. It's just the starting point for this graph. So even though there's two dots, this is the only one that's really happening. So that is actually okay. Only hitting it at one spot. Same thing here. Only hitting it at this spot. This is an open hole. So as we keep going, we can actually say that this is a function. If we do this one here, again, only hitting it one spot all the way through, and so therefore we will say it's a function. I know at the vertical part here it looks like it might be more than one, but it is one. Now we have been dealing with linear functions. You guys have done a lot with linear functions in your algebra class and even in geometry. Y equals mx plus b. You've seen that. The independent variable usually for these are x. Okay, we use x for our independent variable because it doesn't matter what's going on. It's our input value, which again we call x. The dependent variable, the variable that's depending on the input variable, is your output, or the y value. Okay? So, when we're dealing with function notation, you'll see it like this. It's basically saying, I have a function of x, so a function with respect to x, and the function is this. So my input value would be an x value, and I want to know what the output is. So if I look at this one here, it's saying my input value is 255. That's not saying it's f times 255. That's saying that is my input. I'm putting into the problem 255. So we can do this by hand and say, well, f of 255 is equal to 7 times 255 minus 9. And hopefully, when you do that, you get 1776. Now, there's a way to do this on the calculator I want to show you guys. Well, let me find my calculator real fast. That's not it. It's probably this one here. Okay, so my calculator. Alright, I lost my recording again, but it's here. So, I got my calculator now. It's up and running. So, if we look over here at the calculator, what you want to do is go to your y1. So there's my y1. I'm going to input my function. My function here is 7x minus 9 into my y1. There's a few things you can do to figure out what the value is, but the easiest one to do is using your vars button for variables. It's next to program. Click on vars, and then you want y vars. So move over one to the right, and you should see function. We're dealing with functions here, so let's hit enter. And since we put our function into y1, we want to know y1's function. So I hit enter again, and you should get y1 here. What this is saying is the function at y1, and then I want to evaluate that function in my y1 at 255. And you can hit enter, and you get the same thing. Now, let's say I ask you for a bunch. Like, let's say I want to know that function at 236. Quick way to redo that, you hit second enter to bring back the other thing you just entered, and you can type in the new one. So at 236, the function is 1000, or the output value is 1643. Okay, so anyway, that is one way, and we're going to talk about that more in class though, so don't worry about that if you are confused by that. Alright, so back to this. We have a function, y equals 3x plus 1, make a t-table and graph. Alright, well, let's make some values for this. I always like to start at the middle at 0, so that means this is -1, -2, 1, and 2. Again, we can do this by hand and plug in values for each one. So when x is -2, -6 plus 1 is -5, -1, you get -3 plus 1 is -2, 0 gives you a 1, and as you notice this is changing by 3's because your slope is 3. So this should be 4, this should be 7. And if you plug the values in, you will see that. So now we can graph our line. We have -2, -5. We have -1, -2. And we have 0, 1. We have 1, 4. And we don't need that other point actually because it's off the graph. So our function looks like that. And you could have graphed it, you could have found the pattern and just gone, rise over run again, up 3 over 1, up 3 over 1. We're going to do that when we do quick graphs in a couple of videos. Alright, so now let's just do 2 quick questions. You guys could probably do this without my help, but so if you want to try them right now, pause the video and see if you get them right. 2.4 calories burned per pound of weight each hour. The calories burned in H hours by a 110-pound person walking briskly can be modeled by calories equals 110 times 2.4 times H. So for a walk of up to 4 hours, identify the domain and range. Alright, so up to 4 hours, which means we can go either 0 hours to 4 hours. Alright, so I have 0 to 4 hours. So the domain here, and this is how we're going to represent the domain. The domain is all values, and since our domain is our input, my input values can be 0 to 4 for hours. I'm going to say it's all the H values such that H can be 0 to 4 hours. Okay, again, that's just some domain notation, but again, you don't have to, we'll get more into that notation later. If you just want to say 0 to 4 right now, that is fine, but this is how it's going to start looking, this notation. How do we find the range? Well, we have to find the range of the calories burned. Well, you just use your domain values and find the values for 0 and 4. So if you put a 0 in for here, our C value, C equals 0 when H is 0. And then when H equals 4, you get C equals, when you type this all in your calculator, multiply it all out, C is 1056. So that means the range, I'll just put this right here. The range are all the C values, the output values, from 0 to 1056. And that's my range of this problem. Again, it's just what output values can I get between 0 and 4. I can get between 0 and 1056. Graph the function. Use the graph to estimate how long it takes to burn 400 calories. Okay, well, if I graph this, I'm going to say that I have the points. I'm going to just come up with some points. We know 0, 0 is a point. If I put 1 in, and again, I'm going to just be doing this pretty quickly. If I put 1 in for H, you multiply 2.4 times 110, and you get 264. And if I put in a 2, you get 528. So those are my 3 points. I'm going to graph it. So I'm going to go up by hundreds here. Go up by hundreds. And then I'm just going to go over by hours. So this is 1 hour, 2 hour, 3 hour, and 4 hour. So we have 0, 0. So this is hours, and this is calories. I have 0, 0. I have 1. 264 is about there, and 2 and 528. So 1, 2, 3, 528. And if I did it correctly, it should look like a straight line. It's close enough. And we're going to just use the graph to estimate how long it takes to burn 400. So 1, 2, 3, 4. 400 calories is about there. If I bring that down, I would just say H is approximately 1.5 based on my estimation. Now you could easily figure that out using the linear model by plugging in 400 for C and solving for H, but I just wanted an estimate. So that's all you need to do for that one. We're just graphing and getting points. Alright, now we got Spooky Town. Houses will be from 1450 to 2100 square feet. The cost is $75 per square foot. And here's the cost function again. So cost depends on square foot. Give the domain and range. So that's all we need to do is domain and range. So my domain is the value of F in feet, and the value in feet can be between 1,450 to 2100. That's all I had to do for that. The range can be values for C, such that, and this is where you have to figure out the cost, so I need to do 75 times 1450 for the lower end. I'm just plugging in 1450 for feet, and then on the upper end I need to do 75 times 2100, and when you solve you get 108,750 or you get 157,500. So my range, the cost values can range from 108,750 all the way up to 157,500. And again, the input is feet, which is your domain, output, or square feet in this case, and the output is the range, which is the cost. Alright, well, this video went a little over 15. Hopefully it is uploadable. We'll see what happens.